Oh. All right, can y'all hear me? Hi. There we go. Oh, that is so much better. I want to duplicate, I want to extend the changes. Thank you. And pull this back up. Good. Can someone talk to me to make sure that I got the speakers on right?
We can hear you.
Great, thank you. And I'm in a big empty room, so I'm wondering how many people are gonna show up for class and how many are gonna be in the Zoom instead. It's been happening a lot with this particular class. And I understand it. And next thing is to do this. And more people show up in class, there's something I want to talk about. It involves grades. Some differences. Did we do double angle formulas? These lovely things. I was working a problem and I didn't have this available to me and I did it wrong. Because I was thinking this was sine of 2 theta. So I worked a homework problem incorrectly and was getting an answer that was different than what should have been happening. Okay. I saw that the answer was 0. You know, work through that problem again. Okay, have we done this problem? I mean, have we done this in here? I knew we did it in my other class, my Tuesday, Thursday class. Someone talk to me. You can type it in the chat if you want to.
I think we're about to touch on it, if I remember correctly.
So we hadn't come to this slide yet. So this was using No, it's not doing it. It's supposed to be doing it. Oh, my PowerPoint goes on. Isn't that a lovely thing to have happen? That doesn't mean we're gonna have problems in class today. There we go. Ah. Okay. I'm stymied. Because the PowerPoint is freaking out on me. Okay, let's do this. Restart the program. I usually just wait it out, but today I don't feel like waiting it out. I had too much shit happening this weekend. Excuse me for cussing. What's your report back to? There we go. Man, shut this stupid thing down. Okay. Okay. PowerPoint back up. And, oh, this one's remembering where I was. Okay. This is where my PowerPoint has decided where we left off. So I'm backing up. Projectile motions, yeah, I remember talking about this. Okay. Half angle formulas, this is just the same half angle formulas, except it's been squared. Each side has been squared. So if we go back to that slide that had the original half angle formulas, which is going to take me a little bit here. I apologize. So no, that's what they had. Oh, okay. So let me see. Backing up. Double angle. So I went from double angle . So, okay, double angle is that. And, oh, okay, I know, there's someplace else. Oh, this is a problem. Develop the formula for tangent and the sine for, and then for sine. Could have used that one the other day. That's the one I wanted to use. Because we established this identity for the double angle. Right? Because, and where it was tangent to tangent theta minus tangent squared theta. Okay. For the double tangent. And then for the sine, they rewrote the sine of 3 theta as the sine of 2 theta plus theta, and rewrote that as this the sine of the sum of 2 angles. So it's a sine of 2 theta times cosine theta, cosine plus cosine 2 theta times sine of theta. And it's plus between the two products because the angles are being added. If the angles were being subtracted, it would have been a minus sign here. And then using the double angle theorems, sine of 2 theta is 2 sine theta cosine theta. And then we have the times cosine. Cosine 2 theta can be written in one of several ways, and they wrote it this way as the cosine squared minus sine squared. We also have 1 minus sine squared theta, or we have cosine 2 cosine squared theta minus sine theta. I mean minus 1. So you have 3 options for this right here, and they chose this one. They did the distributive property here. They just multiplied the cosine times the cosine, cosine squared. The rest of it remained the same. And here they multiplied in by sine theta, noticing that we have sine theta cosine squared and sine theta cosine squared, so we can combine these like terms and get it 3 times sine theta cosine squared theta minus sine cubed theta. That's not recognized. I mean, we don't. It's not necessarily a formula we would need to use, but it could be helpful. Okay. Now we have sine squared theta, cosine squared theta, and tangent theta. Right. These are formulas, and we could do trig identities to make that happen. Cosine to the 4th, you can write as cosine to the 4th as cosine squared squared. And cosine squared is 1 plus cosine 2 theta divided by 2. And we can square that, which is what they did. 1 times 1 is 1. 1 times cosine 2 theta is cosine 2 theta, and we double it. And then cosine 2 theta squared. And then going to square the 2, and they wrote the 1/2 out front. And yeah, I remember doing this in class. And so what they did was they multiplied in by the 1/4 and got this, and then they deal with and they rewrote this as cosine of 2 theta being squared, I think. Well, no. Cosine 2 theta is 1 plus 2 times. They're just trying to get rid of the exponents larger than 1, and so they wrote cosine squared as a single cosine. And they multiplied the denominators together and brought it out front. And I would have written this as cosine 2 theta over 2, and this is 1 plus cosine 4 theta divided by 8. I would have written them as fractions, not as a fraction times the trig function. And what they do next? Oh, I see what they did. They multiplied in by the 1/8. And then 1/8 plus 1/4 is 3/8. And then 1/8 times the cosine 4 theta is 1/8 cosine 4 theta. And again, I would have written those as fractions, not a fraction times a function. Okay. Okay, solving this, first thing, do they square both sides? The left side equation, except for the factor of 2, is in the form of the double angle formula. Okay, so if we multiply both sides by 2, then we have the double angle theorem. Right? Because 2 sine theta cosine theta is the sine of 2 theta. And that equals 1/2. So what angles in the unit circle, which angles have a sign that's a negative 1/2? And that's what 2 theta is. So you do the inverse sine of those sides. Okay. All right, because sine of 11/16, all right, if you look in the unit circle. Whoops. Just realized, there we go. If we look in the unit circle, I always go back to the unit circle. I know sine is going to be negative over here and sine is going to be negative over here. And this is the point, square root of 3 over 2, comma, negative 1/2, where this is a cosine of 11 pi over 6. And this is the sine of 11 pi over 6. And if I add pi over 2 to it, or k times, where k is a whole integer number, so you're either going around once or going back once, because k could be negative as well as positive, so you could be going either direction, and you still wind up there. But we also have it over here. I don't know why they didn't include this one. Because this point over here, for 7 pi over 6, we have negative square root of 3 over 2 and negative 1/2. So they both give us negative 1/2. So 7 pi over 12 and 11 pi over 12. If you double those, that will give us this angle, these angles. See, where did I put it? Oh, there it is. Now, okay, so they did this one. And so that means this angle and divide through by pi. Dividing through by 2, sorry, or you multiply by 1/2. Multiplying by 1/2, 11 pi over 6 became 11 pi over 12. Multiplying by 1/2 here gave us pi k. All right, 11 pi over 12 plus pi or minus pi. Okay, so we want to go both directions. So minus pi, we get a negative pi over 12. And negative pi over 12 is right in here, which is 11 pi over 12. No, negative pi over 12. Negative pi over 12 is over here. No, it is here. It's the same angle. Right, so we have this one here and this one here. And we have 11 pi over 12. And we have 23 pi over 12. Which brings us back to the same angle. This is the same angle as this one. It's just gone around once. 11 pi over 12 is over here. 11 pi over 12 is over here. And then 23 pi over 12 is over here. And then we have 30 pi over 12. That's going from here. No, going from here and then going around again, back to here. So that's one full revolution around. So that's not in our range, I mean our domain from 0 to 2 pi, not including 2 pi. I didn't include 2 pi in the domain. And then, okay. So they did both of them. And then divide by 12, I mean, multiply by 1/2. And so you get 7 pi over 12. 7 pi over 12 is right about here. And you add pi to it, you get right about here. And so now we have four angles that give us the two angles that are 7 pi over 6 and 11 pi over 6. And they went and found those angles. Okay, so 7 pi over 12 is this one. 19 pi over 12 is this one. Because if I take 1/12 away, I get 18 over 12, which reduces to 3/2. So that'd be 3/2 pi right here. Which would be this angle. A quadrantial angle. And then this one is outside of our domain from 0 to 2 pi. And this one is outside of our domain from 0 to 2 pi. And so it'd be just these two angles. As well as these two angles, because these two angles are inside our domain where these two are not. One's less than 0 and the other is greater than 2 pi, so those won't be included. Okay, so the solutions are those four angles. So there's our solution set. Is those four angles. Yeah, I did this one. I remember doing this one. Well, okay, these are sine squared of alpha over 2 is 1 minus cosine over 2. And then cosine squared of alpha over 2 is 1 plus cosine alpha over 2. And tangent squared of 1/2 alpha is 1 minus cosine divided by 1 plus cosine. Yeah. So the half angle formulas is just taking these formulas and square rooting them. So I square root this one and I get the square root of 1 minus cosine alpha over 2 I square root this to get cosine. This is gonna be the square root of, and then it's gonna be plus or minus because I took the square root. And so the plus or minus depends upon what quadrant alpha, half of alpha puts you in. So if alpha is 7 pi over 4. No, half of alpha is 7 pi over 4. So alpha takes you into the third quadrant, so it will be negative. Cosine of that angle would be positive, and sine of that angle would be negative. Okay. So I can rewrite cosine of 75 as the cosine of 150 degrees. 150 degrees is right here. That is what? That's 5 pi over 6. And so this point here is negative square root of 3 over 2 positive 1/2. Okay. So, well, I mean, 150 over 2, I forgot to do that. And so this is going to equal the square root. And since we're in this quadrant, that means it's going to be negative. Or is it? No, 1/2 of it is over here, because 75 degrees is over here. So it's going to be, this is going to be positive. So it's going to be 1 minus the cosine of 150 divided by 2. And the cosine of 150 is a square root of 3 over 2. The negative square root of 3 over 2. So this is 1 plus the square root of 3 over 2 divided by 2. Interesting. Okay. So we get 1/2 plus the square root of 3 over 2 square rooted, or the square root of 1 plus the square root of 3 divided by 2. Wait, that's going to be a 4 here. So this is going to be 2 times divided by 4. Because this would be 2/4, and so you add 2 to the square root of 3, and your denominator is 4. Which becomes 1/2 plus the 4th root of 3 divided by 2. But that's not an answer I expect you all to go to. So let's see what they did there. 75 is the first quadrant, so cosine will be greater than 0. And so they use that formula. What did I use minus? I did minus, didn't I? Should have done plus. I don't know why I did minus. It should have been a plus. So this should have been a plus here. So this would have been a minus here. And I would have just changed my signs here. That's all. It's just a change in sign. Didn't change the numbers, it just changed the sign. Oh, but it should have been plus. I changed it. So those would have, okay. So these would have become minus and where those were plus. Square root of 3/4. Square root of 3 is, okay, so that's gonna be, so this is just above 1. Actually, it's gonna be less than a half. They simplify, yeah, they simplified it to this. Okay. I just had a sign wrong. And oh, okay, they took the square root of the denominator. Yeah, I didn't need to do that. Yeah, sine of a negative angle is the negative of the sine of the positive angle. And so now I can do the negative of the sine of 75 degrees. Well, 75 degrees is in the first quadrant. So sine is positive there. So we're going to get a negative number. So it's going to be the negative of the square root is going to be the similar formula, except this one is going to be minus. So it worked out the same as I did here before, but with the plus sign instead of the minus sign. So I actually worked this problem, not the cosine problem. Now, the only additional thing I needed to add here was the minus sign out front because the minus sign here. So with trig functions, it's always easier to deal with the positive angle. So we use the even odd nature of the trig functions to determine the way we're going to do this. Okay, cosine alpha is the negative 2/3, with alpha being in the third quadrant, right, between pi and pi/3. So we're in the third quadrant. So that means if we go if we go 2 units in the negative direction and our radius is 3, so this is negative, this is 3, so this is going to be a negative here as well. Well, 3 squared minus 2 squared is 5. So this is going to be the square root of 5. And it's going to be negative square root of 5. So now I just need to figure out, rewrite this in terms of the half angle, which is the square root of 1 minus cosine alpha divided by 2. And cosine of alpha is a negative 1 minus a negative 2/3, which is 1 plus 2/3 divided by 2. And I'm going to rewrite this numerator as a single fraction. So that's going to be 3/3 plus 2/3, which is 5/3 times 1/2, right? Dividing by 2 is the same as multiplying by 1/2, which is the square root of 5 divided by 3. Rationalizing the denominator, we get the square root of 15 divided by 3. Multiply numerator and denominator by 3, and then take the square root of the denominator. So you get 15/9, and 9, the square root of 9 is 3. And so that's how we got that. Oh, that should have been a 6. Ah. Excuse me. How are they gonna find out here? This is wrong. I don't see how they got a 5 out here. That should have been a 6 down here. So this would have been 30 square roots of 6, because I forgot to multiply the 2 times the 3. That would have been either a -1, or I wouldn't have taken off points for that error. Okay. And so the sign will be negative, or cosine, so 1 plus cosine alpha. So you're gonna subtract 1 minus the square root of 3, which is 1 over this. 1 minus 2/3 becomes 1/3, and half of 1/3 is 1/6. And so the square root, the negative square root of 1/6 is the negative of the square root of 6/6. Yeah, that previous problem, they forgot to keep the 5 underneath the square root symbol. So there are more mistakes in this PowerPoint than there have been in previous ones. And it's simply because people aren't paying attention to their job. All right. And so they're saying the same thing here. And we know what the cosine of alpha is it's negative 2/3. And so my numerator becomes 5/3, and my denominator becomes 1/3. And so multiplying, so I'm going to multiply my numerator by the reciprocal of the denominator, which gives me 5. So it's a negative square root of 5. All right, so we have 2 formulas for, they wrote, unlike what they did with cosine and stuff before, where for cosine of 2 theta, they had 3 formulas. They could have written it as 1 formula where they're all equal to each other. That's essentially what they did here. We have 2 formulas for the tangent of half angle. It's 1 minus cosine alpha over sine of alpha, or it is tangent of half of alpha is the sine of alpha over 1 plus the cosine of alpha. So you have either of those to choose from when you have alpha over 2 in the tangent. So which one do you use? Well, it depends on what you need to find, what you need to do. That's all. Sum to product, product to sum and sum to product formulas. Okay, express products as sums and expressing sums as products. So sine alpha times sine beta is 1/2 cosine minus the difference of the 2 angles minus cosine the sum of the 2 angles. And all of these have 1/2. Cosine alpha, cosine beta. It's going to be 1/2 the cosine of their difference plus the cosine of their sum. So notice that these 2 are very similar. The only difference is whether you're subtracting or adding the 2 cosines. And the third one, when you're multiplying sine and cosine of two different angles, here you're multiplying cosine of two different angles and sine of two different angles. Here you're multiplying sine and cosine of two different angles. Well, now it's going to be sine inside, and it's going to be a sine of the sum plus the sine of the difference. Now, to follow the same pattern they did up here, I would have put this first, just to follow the same pattern, because with addition, you can change the order of the addition. So this could be a beta plus alpha instead of alpha plus beta. But I would have put this first and this second, just to follow the same pattern. That's all. Because it's easier to remember, or it makes it more confusing. Either way. So we have these. So now it's just a matter of applying them into a situation like this. As a sum using only sines or only cosines. So this will be the what is it? Okay, cosine. So it's going to be cosine of 5 theta minus 3 theta. Is it minus or plus there? It's minus. Okay. So with sine, you're going to be subtracting the 2, and with cosine, you're going to be adding the 2. And so it'll be cosine of the difference minus the cosine of the difference minus the cosine of the sum. So it's going to be the sine of 2 theta minus the sine of 8 theta. Well, let's let that do it. So you cosine of the difference minus the cosine of the sum. So we get and 1/2 times that. Now we could use a half angle here, but they just wanted either cosine or sine, and so we'd be done. Okay, so formula 2, because we're multiplying cosine of 2 different angles, then it's going to be the cosine of the difference plus the cosine of the sum. All right, the cosine of the difference plus the cosine of the sum. So this becomes cosine 3 theta, and this becomes cosine 5 theta. And you take 1/2 of that sum. Okay. I can't remember the formula. Surprised. Oh, this is sine, right? And it's going to be a sine of the sum plus the sine of the difference. The sine of the sum of the 2 angles plus the sine of the difference of 2 angles. So you get the sine of 8 theta plus the sine of a negative 4 theta. And I can bring that negative sign out, so it becomes minus the sine of 40. Right? Because sine is an odd function, the sine of a negative degree is the negative of the sine of the positive. And then after you find that difference down here, you multiply by 1/2. Okay, any questions? If you have questions, or if I'm going too fast or whatever, please don't hesitate to ask or stop me or whatever. It's brighter. Okay. Now, sum to product. All right, if you're adding the sine of two different angles, then it's going to be twice the product of the sine of the sum divided by 2 times the cosine of the difference divided by 2. Please notice that they are very much similar all the way down. It's just, are you, what are you doing? Are you subtracting or adding the two angles? Okay. When it's sine, when you're adding the sine, then you're going to take the sine of the sum and the cosine of the difference and divide by 2. And you multiply that product by 2. If you're subtracting the two sines, then it's going to be the sine of the difference over 2 times the cosine of the sum over 2. So you're switching these two fractions here to go from minus to plus, going from plus to minus. Cosine, it's kind of a similar deal, except the change is what trig function you're going to use. If it's if you're adding the cosine of two different angles, then it's going to be the product of two cosines of the sum of the sum of the two angles divided by 2 times the cosine of the difference divided by 2. And if you're adding, then the cosine becomes sine. So it's the same deal, except now it's going to be sine instead of cosine, and it's going to be negative 2 times that result. You will get a formula chart with all of these things on it. I know I keep promising it. Okay. Here I'm subtracting the sine. And so that's going to be 2 times let me back up. Okay, it is sine cosine. Okay. So it's going to be 2 times the product of the sine of the difference divided by 2 times the cosine of the sum of the 2. Okay. So we're going to subtract and get 4 pi over 2, which leads us to 2 pi. And we're going to add, which gives us 8 pi over 2, which leads us to 4. I keep saying pi. 6 theta minus 2 is 4 theta divided by 2, which is 2 theta. And this becomes 8 theta divided by 2, which is 4 theta. So we have 2 times sine of 2 theta times the cosine of 4 theta. Next. Oh. Now it's going to be the cosine. Okay, so we're going to use formula 8, which is the cosine of the sum times the cosine of the difference because we're adding, right? If we were subtracting, then these two cosines would be sine. And so you get 9 theta over 2 for here. And you get 5 theta over 2 there. And this doesn't simplify. Okay, please notice that they did not multiply in by 2 because this is a number that you're multiplying by 2. This is not an expression where you can multiply in. Okay. Right triangle trig. Find the value of trigonometric functions of acute angles using right triangles. Use the complementary angle theorem. Solve right triangles, applied problems. I'm gonna shy away from this last one. But it is useful in real world applications. Just ask pilots. Okay. Cartographers. Oh, so okay. So this is the right angle trig ratios, which we've already done. This is just a review of it. Okay. Sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Sine is just the reciprocal. I mean, cosecant is just a reciprocal of sine. Secant is just a reciprocal of cosine. Cotangent is just a reciprocal of tangent. It's kind of nice how it works out that way. So find the 6. All right, first of all, we need to find out what the opposite side is. So use Pythagorean theorem. 13 squared. What is 13 squared? That's one of the first 16 perfect squares. If you commit those to your brain, you know that 13 squared is 169. And 5 squared, you should know from elementary school. And so 169 minus 25. What is that? 144? Is that 144? Did I subtract correctly? Someone answered me.
Yes,
I
it
didn't
is.
hear. What? I keep talking over you.
It's correct. 144.
Okay. And what's the square root of 144? That's one of the first 16 perfect squares you should know. And 144 is one of those squares you should know anyway. What is it? What's the square root of 144? What number do you square to get 144?
12.
12. This is a Pythagorean triplet. Integer numbers that form a right triangle. And the multiples, the same multiples of these numbers. So 10, 24, and 26 also form a right triangle. Okay, so now we know what these are. We can find, we don't need to, they're not asking what theta is. That would involve the calculator. This just involves sine of theta is opposite over hypotenuse, which is 12/13. And this is the answer we look for. Don't punch it into the calculator. This is the answer. If all you give me is the decimal answer for the answer, I'll take some points off. Because I'm looking for the integer answers, or the fraction answers. And so cosine of theta, well, that's adjacent over hypotenuse, so that's 5/13. And the tangent of theta is the 12 divided by the 5. And now you know that cosecant theta is just a reciprocal of the sine, which is 13/12. And the secant, which is just the reciprocal of the cosine, so that's going to be 13/5. And cotangent is just going to be the reciprocal of tangent, which is 5/12. The secret is getting this side here. And they just gave us one that is a Pythagorean triplet. And there's one involving 7, I can't remember. Oh, 7, 25, and 26. Yeah, so 49 plus 625 is 674. So 26, no, that's not right. What's 24? But that's not right. So it's not 6, 9, and 6, 7. I can't remember what it is right there. Oh, I put it right there. I used to know some of the basic Pythagorean triplets. I know 7 is one of the sides, and there's 2 other integer numbers. I just can't recall what it is right now. And so given the 2 sides of the triangle, we can find the opposite side by using the Pythagorean theorem. Yeah. You 144 times square root 144. And so using those, we can find the 6. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant, secant, and cotangent. They get the same values. Right. It's nice to know they didn't get any typos there. Okay. Yeah. We want to maximize the volume going down the rain gutter. And this is a little complicated, and I won't throw a problem like this on you. So we're passing it by. So complementary angles. What are complementary angles? Anybody remember the high school geometry? Complementary angles. Angles A and B are complementary if they add to what number? Anybody recall? To be complementary angles, what do they have to add up to? This should be helpful. In a right triangle, the other 2 angles are complementary. Right? What do all the angles inside any triangle add up to? Anybody recall? Any triangle, the 3 angles, their measures, what do they add up to?
180?
180. So if one of the angles is 90, what's left?
90?
90. So what do these two angles have to add up to? You just said it,
90.
90. That's the definition of complementary angles, two angles whose measure add to 90. The sine of B is the cosine of A. Right? Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. So the cosine of A and the sine of B give you the same number. So if A and B are complementary, then this is true. The cosine of B will equal the cosine of A. And the cosine of B will also equal the sine of A. And the tangent of B will equal the cotangent of A. And the same is true with the reciprocal trig functions. Because you're just flipping the fractions. So that's what we're talking about when we talk about the complementary angles, that and their cosines and sines and cosecants and secants and tangents and cotangents. You get those wonderful things that apply, that happen. All right. Complementary angle theorem. Co-functions of complementary angles are equal. Co-functions. What do you mean co-functions? What are co-functions? So the angle is 79 degrees, so I want to find the cosine of its complementary angle, so I do 90 minus 79. So the cosine of 11 is the same as sine of 79. We'll do the same thing here, but instead of with 90 degrees in radians is pi over 2. So we're going to do pi over 2 minus 18 pi over 18, right? So this is 9 over 18, and it's going to be cotangent. And so the cotangent of what? What's 9? So that's 8 over 18, which is 4 pi over 9. Right, so this is going to be the sine of pi over 2 minus pi over 3. Well, this is going to be 3 pi over 6, and this will be 2 pi over 6. So this will be 1 pi over 6. And then again, pi over 2 minus see 5/12 is less than a half. So I can do 1/2 minus 5/12, which is 6/12. So the cosecant will equal the secant of pi over 2 minus the angle, which is 1/12 pi. Where did I get 6 from? Oh, the previous problem. Yeah, 5 pi over 12 is 1/12 pi away from pi halves. Okay. So properties of a right triangle for right triangle show we have this is true. Boom. Well, yeah. Obvious, right? I think it's obvious, but in mathematics, if it's obvious, we need to have a theorem or a definition that says that it's obvious. And so that's what this is. So we state the obvious, we make it a theorem. Because we can prove that to be true. Okay, so now we start solving right triangles, which is you want to find the missing measures. Find the missing measures. So I want to find out what A is. I want to find out what C is. I want to find out what B is. Well, I know what B is. What is B? Someone tell me what B is.
$55.
Yeah, 55. I was thinking this was 36. I don't know why I misread it. Okay, yes, this is 55 degrees down. So now we need to find either A or C. So we can find find C or A. So if I find A, then I can find C. If I find C, I can find A I end up using Pythagorean theorem. Let's see what they do. And so use A and C, we use the fact, okay, so they're going to use A and C. Why A and C? Oh, to find them, we use that the tangent and cotangent, all right. Either way. And I go to sine, cosine, and tangent. I don't use the cosecant, secant, and cotangent. I traditionally go to sine, cosine, and tangent because it's simpler and easier, and the calculator has those in them. So now we solve for A and C. All right. 4 times the tangent of 35, yeah, because if I multiply both sides by 4, I get this, and then I just punch this into the calculator, and they rounded it to 2 decimal places. They did not do with this problem and ask you to round it to 2 decimal places. But if it does not ask you to round to a specific number of decimal places, round to 2 or 3. So if you get an exam question, it doesn't ask you to round to a certain number of decimal places, round to 2 or 3. We'll go to 3 and then round to 2. 2 is good enough. Okay. And now C, okay, because we multiplied, basically we just switched the C and the cosine of 35. And so I do 4 divided by the cosine of 35, which is easy enough to do in the calculator, and we get 4.88. Or I could have done 4 squared plus 2.8 squared, and then square rooted that, and it should come close to 4.88. It probably wouldn't be exactly the same, but it'll be very close to it. Because we rounded. That's why it wouldn't be the same. Oh, wow. Well, tangent of B equals 4 over 2, and tangent of A equals 4 over 2. So tangent of B equals 1/2, and tangent of A equals 2. Because 4 divided by 2 is 2, and 2 divided by 4 is 1/2. So I do the tangent inverse of 1/2, that'll give me angle B, and I subtract that from 90. And that'll give me A. Or I can do tangent inverse of 2, and that'll give me angle A, and I divide, and I subtract from 90, that'll give me angle B. Now, 4 squared plus 2 squared, 4 squared is 16, and 2 squared is 4. 16 and 2 is 20. Square root of 20 is 2 times the square root of 5. So C is 2 times the square root of 5. All right, square root of 20 can be written as 4 times 5. This is where knowing the first 16 perfect squares comes in handy, because I know I have a perfect square that is a factor of 20, so I can take the square root of 4. So this is the square root of 4 times the square root of 5. If you have a product, you can that you're taking square root of a product, you can write it as the product of the 2 square roots. And so the square root of 4 is 2. So that's how you simplify this. Believe it or not, this is simplified because you're taking out all the square roots. Okay. So, and they typed it in the calculator and rounded it to 2 decimal places. Find angle A by using the fact that tangent. So the inverse tangent of 2. So yeah, always make sure it's in. They're asking for degrees. Well, here they're doing it in degrees. And so they rounded to 1 decimal. Yeah, degrees, they almost always round to 1 decimal places, 1 decimal place. And the length of the sides, they round to 2 decimal places. It's just conventional. I don't know why it's that way, but that's the way it's happened. Okay. And then they subtracted that from 90 to get 26.6. So this angle is 26.6 degrees, and this angle is the 63.4 degrees. A straight trail leads from the Alpine Hotel to an elevation of 800 feet to a scenic overlook. The elevation of an elevation of 11,100 feet. The length of the trail is 14. Okay, so this is at 800 feet of elevation, and this is 11,100 feet. 8,000. Okay, and so this side of the triangle here is 3,100 feet, because 11,100 minus 8,000 is 3,100. What are they asking for? What's the inclination? Okay, or the grade. And so when you're talking about roads or pathways or anything like that, we're talking about the grade. The grade is how many degrees off of the horizontal this is. So the grade here is the degree of B. Well, I know this number, so I can use sine. The sine of B is 3,100 divided by 14,100. Dropping the zeros, we get 31 divided by 141. And we take the inverse sine of that. and it gives us 12.7 degrees, which is a little steeper than what they require for wheelchair ramps. Did you know that? A wheelchair, well, I don't know if that's the right degree. No, it's 1/12. That's so you move 12 feet per one. So that's a different thing. Okay. But okay, the inclination or grade of the trail is approximately 12.7%. So it's almost 13% grade. Okay. A lighthouse stands 100 feet high above. Oh, I don't like these problems. I really don't like these problems. But they're trying to figure out what the line of sight is going to be. So what's this angle for the line of sight? What, it says it can see 26 feet in the distance. So they want to verify the accuracy of this statement. So you solve this for this distance and see, does it equal 26 miles? Well, this entire distance, I'm adding the 400 to the 3960, which gives me 4360. And so we're talking this angle, so we're talking cosine of this angle would be let's see how they do it, because that confuses me a little bit sometimes. Because I get hung up on the fact that we got this circle here. How do we get this formula? What is this from? Because this is in feet, not miles. So they're converting the 400 feet to the number of miles. So that's what they're doing here. So 1 mile is 5280 feet. Okay, 5,280 feet. That's something I've memorized since I was in what, 4th or 5th grade, maybe 6th grade. I don't know. I've known it ever since. I don't remember not knowing it. So this will be a decimal number here. And divide it out, so it's approximately 0.99999. It's not 1, so you don't want to use 1 when you do the inverse cosine. Or do I want to do inverse cosine? So, okay. So it's approximately, it's less than half of a degree. Now, this side over here is going to be the sine. This number is going to equal the sine, or the sine of this is going to equal S over 3960. Well, they're multiplying by 60 degrees. So it's 27 minutes. I wouldn't use that. I don't know why they did that. Why did they do that? Because they converted it to nautical miles. That's why. They're bringing in information not presented. The brochure does not include whether the distance is measured in nautical or statute miles. So if the distance S is in nautical miles, then the measure of an angle in minutes is the number of nautical miles. So one minute of a degree is 1 nautical mile. So this is approximately 21.27 nautical miles. But the number of but the distance S in statute miles is given by the formula R equals R theta. So the radius and where the theta is measured in radians. And so, let me see. They don't have radians here, so they would convert this to radians. And R is what was that again? 39. Yeah, 3960. Number I probably should have in my head. So I would recalculate this, but turn my calculator into radians and get this number. So we want to use a lot more decimal places because we get really small numbers here. And so this is 24.5 miles. So if it was nautical miles, they were way off, 21.27 nautical miles. And they're talking standard miles is 24.5 standard miles, which is 1.5 miles less than the 26 miles. The brochure kind of overstated the distance a little bit. So they could probably have said 25 miles and it would have been okay, but they went that extra mile, which I don't know if you want to forgive them for that. I don't know. Bearings. Oh God. Bearings are a totally different way of looking at these angles. So either it's an angle off of north or it's an angle off of south. So this angle here is 30 degrees, it's north 30 degrees east. Where this angle here is 70 degrees west. It's north 30 degrees, 70 degrees west. So these are going to be south 20 degrees east and south 50 degrees west. And if it is due east, then that's what they say, due east or due west. Due west or due east. I'm sorry, I pointed in the wrong direction or used the wrong word. An acute angle between the ray and the north-south line is 20 degrees. And the bearing, because the point is going south of the original of our reference point, bearings are only good off of a reference point. So when they talk about airplanes and what bearing they're on, well, it's from the airport. So the plane may be traveling this way, but at this position, this is its bearing. And then they'll give the distance from the airport. And ships at sea is the same thing. But what's the reference point? Okay, well, the ships at sea, the reference is either a point, either a port for another ship, or whoever they're in communication with. So bearings depend upon what your reference point is. Because if my reference point is now over here, then this point has a different bearing. Its north looks to be about 50 degrees west of this point. So, yeah. And I won't do anything with bearings. I think you'll have homeworks on it, but I won't do anything with it. And now we're on the law of sines and cosines. Well, we'll start with laws of sines. Laws of sines are easy. But here we have an obtuse triangle. This is angle A, B, and C, and this is side A, B, and C. Here we have an acute triangle. Let me make it acute. And we have angle A, B, and C, and we have side A. Oops. Okay. So the sides are in lowercase letter, the angles are in uppercase letters. That's always how we do it in mathematics. Angles, when represented by letters of the alphabet, are always capital letters, and the length of sides will always be lowercase letters. And the side is opposite the angle. And so lowercase b is opposite angle b. And law of cosines is quite simple. The sine of A divided by A is going to equal the sine of B divided by B is going to equal the sine of C divided by C. Doesn't matter which. Doesn't matter. Obtuse, acute. If it's a right triangle, sine of 90 is 1. So it does, does it work for? Right triangles? I'm not too sure. Oh, this is solving side angle and angle side angle. And then side angle. Then they don't have side angle side. Yeah, I think the first one might be a typo. The side angle. I think that one has to solve an oblique triangle. Okay, so these are oblique. That means there's no right angle. Okay, you come across the term oblique before. Oblique asymptote, which means it's not at right angles to the vertical asymptote. Well, I'm going to hold up here. And something I need to talk to y'all about. My lab math. Right today, I haven't done it yet, because I need to talk to y'all first, to tell you what I'm doing. My lab math, a lot of people haven't even started any of the homeworks in there. That's a bad thing. I know I don't use that grade as a grade, but you can't get a good grade in this class if you don't do the homeworks. An early alert is supposed to go out today. I mean, I'm supposed to put those in today. Your early alert is based on how much homework you've done. You, if you haven't done the homeworks for the first exam, you will get an early alert saying you're at risk of failing. This doesn't mean you're gonna fail. This means you need to start doing the homeworks. I can draw a direct correlation between exam grades and whether or not you've done your homeworks. Yeah, I've been awfully disappointed with the exam results. Less so with my pre-calculus classes, but more so with my college algebra classes. My college algebra classes, more people there haven't done the MyLab than my pre-calculus classes, but my pre-calculus classes are pretty bad. I've gotten awfully upset this semester because people aren't doing their homeworks and people aren't doing well on the exams. I should have been more observant of what was going on in my math lab and been in your faces more often than I am right now about this. Because you have to go in there and do the homework so you can do well on the exam. Just doing the review for the exam is not enough. The review for the exam is to help you organize your thoughts for the exam. The homeworks are supposed to help you get ready for the exam. Listening to me rattle on, I know I have a boring voice, I know I have a boring presentation manner. But what I'm doing is I give you the information so you can do the homework. If you don't understand the homework, you ask questions in class, you send me emails. I have somebody in my Tuesday, Thursday afternoon class. He sent me about a half dozen emails this weekend asking, how do I do this problem? I don't remember this thing. What's going on here? I'm confused by the second part of this problem. And I do what I can to help him. Yeah, through email, it's not always easy. At which point we could set up a Zoom meeting, but I don't like to do Zoom meetings over the weekend. So please, get in there and start doing the homeworks. Start with chapter 7 and move on, and then go back and redo chapter 6 as you start getting caught up. Because I will keep using those for the first exam, even though the due date has passed. I don't ever close them out after the due date. Okay. You're going to have the second exam in 2 weeks. Start doing the homeworks. Start asking me questions in class. Start sending me emails, asking me things. If you're on campus, go to the math lab, go to the STEM lab. You have tons of tutoring opportunities on campus. You can use something called, and I haven't sung its praises this semester, but it's an excellent resource. Khan Academy, I think I mentioned it in here at least once. Use it. And this one is free. There are plenty of math tutoring sites out there that are paid. Do what you can. I was a tutor. Well, there's something called SuperPro. It's a paid tutor. I did that for a while. I can't do it this semester because I have too much going on. Oh, this is an M, not an E. Yeah, sorry. Okay. Yes, I'm chastising you a little bit, but it's because I want you to do better. I want everybody to pass. I want people to make a B or better. So please, please, do the homeworks. If you're way confused by a question, there's a button called Ask the Instructor. Use it. I expect to be swamped with emails from my lab, which is fine. That's what I'm here for. I'm here to help you understand it. I know pre-calculus is confusing as hell. It's not always easy because you got all this weird stuff going on. And the trig identities are really confusing. I understand that. You don't have to memorize the trig identities. You just have to be able to use them and figure out which one to use, where and when. So please, please, please. Yeah, I'm gonna quit now. Y'all have any questions for me? I'm here to answer any and all questions. If you have concerns, if you don't want to voice them to the class, do a private message through the Zoom, a direct message to me in the Zoom, or send me an email. And we can talk about things. I've been having a bunch of people drop out. More than I've ever had in the past. A big part of it is Zoom. Because people don't ask questions through the camera. People are more likely to ask me questions when they're sitting in front of me in the classroom. That includes that student in my other pre-calculus class. He was through Zoom and decided he didn't think that was good enough, so he can't. So now he comes to class every day and bugs me in class, asking me questions, asking for clarification. And I have other people in that class who point out my mistakes. I need that. I need to point out my mistakes. Okay, I'm gonna quit now. Can you tell I got upset this weekend? And I feel like it's my fault that y'all are doing so poorly. Because I haven't been pushing enough and I haven't been asking for questions enough. So. Okay. Y'all are free to go. If you have questions, go ahead and hang around. Questions or comments? Thoughts, hopes, wishes, dreams, concerns? I can help with some, but not all. Yeah, my stats professor had pretty much had the same conversation with us after the first exam we had with him. And his big thing was, y'all didn't ask me any questions in class. My only defense was I didn't know enough to ask questions. I just know it was big. It was just all confusing to me. I barely passed his class, but from that point on, I kept coming to his office to ask him questions and stuff. Okay. So I'm gonna go ahead and close the meeting. And we'll see you on Wednesday.
Thank you.
See you later, Sarah. Y'all doing okay?
Question, Professor.
Yes.
On the last exam, how do we know what we got on the grade?
I haven't posted it yet. I'll post it in, I'll post it into Canvas.
Okay.
I meant to get that done this weekend, but things got very, very hard for me.
No problem. Thank you. Have a good one.
So, yeah, I'm not gonna give anybody a family grade for the midterm grade. Okay, and the grade I give you for the midterm grade will not be your grade. I mean, it's not set in stone, you know, because grades can change. And I may do later on, I may throw out a quiz or something that can also help with that grade as well. Because I feel like it's my fault. And so I have to do something to help your grades. In my college algebra class, I think out of the three classes, I think I've had four passing grades out of 3 classes. So. And that was an easy test. By any standard, that was an easy test. Okay, I'm gonna go ahead and say bye-bye.